from halides. So here we take 1,1,1 trichloroethane. So Cl, 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 here CH3 and 2 molecules of trichloroethane, CH3. It reacts with Ag powder. How many Ag? How many silver? 6 Ag. So 6 Ag reacting with 6 Cl, so that you will get 6 AgCl, and what will happen? These 2 carbon atom will be connected. No extra hydrogen atom is there, so you will get CH3, C triple bond, C, CH3. So the answer is, what is the answer? 2-butene is the answer. So this is one of the method for preparation of ethynes or alkynes. The equivalent conductance of NaCl at concentration C and at infinite dilution are lambda C and lambda infinity. Then respectively, then the correct relationship between lambda C and lambda infinity is given as, and this is actually, you know, in case of weak electrolyte, as you go for dilution, the conductance increases, right, because the ionization of the weak electrolyte increases. Whereas in case of strong electrolyte, they are called strong electrolyte because they completely get ionized. But still, these ions of the electrolyte, they do attract each other. So if you go for dilution, it slightly increases the conductance. Okay, slightly increases the conductance. That is what given by which equation? Debye-Huckel-Onsager equation. Debye-Huckel-Onsager equation. That equation is given as, according to your textbook, it's a long derivation. According to your textbook, lambda m is equal to lambda ion naught m minus C raised to half, and here a constant is there. This is the concentration, and the constant what they have given in your textbook is AC raised to half. So if you substitute the value what they have given, lambda C is equal to lambda infinity minus the B is the constant. So B root C. So which option? B. Direct question. Debye-Huckel-Onsager equation is another important concept. Is that all right? Resistance of 2 molar solution. How do you find out the molar conductance, molar conductivity? Molar conductivity is equal to kappa by C. Kappa, this is a Greek letter, okay, is what we call specific conductance or conductivity. And this C, here the question is you have to find out in meter per mole. So you have to multiply it by 1000. C you have to multiply by 1000. Upper, it depends on which unit. So here, if you want to find out the molar conductance, you need to know the concentration. Concentration is given, it is 0.5 molar. This kappa is not given. This kappa depends on the nature of electrolyte and also the concentration. So here they have given a set of values. The resistance of 0.2 molar solution of an electrolyte is 50 ohm. We can write it as per Siemens. Then the specific conductance of the solution is 1 point, kappa is given, it is 1.4 Siemens per meter. Okay, so let me in a faster way, let me recall what is the conductance, all those things. So you know that R is directly proportional to L by A, area of it is directly proportional to the length of the rod, inversely proportional to area of cross section. Then when you remove the proportionality, you can write rho into L by A, and you know that conductance is equal to 1 by R. When you take conductance is equal to 1 by R, then how do you relate G is equal to 1 by rho into L by A? Sorry, A by L, right? This 1 by rho is what we call kappa, right? So, in terms of resistance, how do you write kappa? Kappa is equal to 1 by R, that is G, into L by A. You understood this? So, kappa is equal to 1 by R into L by A. This is what we require. And L by A is what we call cell constant. It is a constant, otherwise we will not call it as constant. And kappa depends on the molar concentration. So, 1 by R into L by A. Actually, I need to get kappa at what molar concentration? 0.5 molar concentration. What they have given? 0.2 molar concentration conductivity is given. So, what you can find out? L by A you can find out. So, L by A is equal to kappa into R, that is equal to 1.4 Siemens per meter into what is R? 50 per C, right? Then what is the answer? 50 into 1.4? 70 per meter, right? Now you have to find out this kappa. To find out kappa, what you require? Cell constant and R. So, kappa is equal to, we are finding out at 0.5 molar concentration. What is R? 280, right? 280 per Siemens into what is L by A? 70 per meter, right? So, you will get what? You will get 0.25 Siemens per meter, that is kappa. So, if you substitute the value over here, what is kappa value? 0.25 Siemens per meter divided by, what is the molar concentration? 0.5 molar. Instead of writing, because moles per decimeter cube, I need it in meter cube, otherwise that deci will be staying there only. So, 0.5 into 1000 moles meter cube. This 1000 is added in order to make it into moles meter cube. So, what will be the answer? You will get 0.25 by 0.5 is equal to 0.5 into 10 raised to minus 3. So, you will get Siemens per meter square, Siemens meter square per mole. So, what is the answer? 5 into 10 raised to minus 4. This question is on name reaction called Kolbe's reaction, right? So, when phenoxide, they say that phenol is treated with sodium hydroxide. When it is treated with sodium hydroxide, what will be the product? Treated with sodium hydroxide, Kolbe's reaction will happen. You will get OH, COOH, right? If you go for acetylation of this reaction, acetylation will happen. Here, then what will be the product? Acetylation will happen over here because it is treated with what? H plus Ac2O, right? Acetic acid. Then where it will happen? OH group. So, acetylation of OH group will give what? See, if it is an alcohol, you could have expected acetylation over here. What they have taken? Acid. Acid with alcohol. So, what is the answer? It will give D. Alcohol is to ortho position because Kolbe's reaction give a product orthohydroxy acid. When it is orthohydroxy acid, you will get this product. Which one? Which one? D option. This question also on familiarity on certain complex reactions. Most of the complexes we prepare by substitution reaction, and this, because you need this, if you look at this reaction may be feasible, but the familiarity will make you to answer to the question. Answer to the question is A, that complex will dissociate in presence of acid to give CO2 plus 5NH4 plus Cl minus. First one is the answer. This question is on rubidium. Atomic number of rubidium is 37, it's already given. When atomic number is 37, you can write down the electronic configuration. Krypton 36, what is the rest? 5s1. The easy way to write electronic configuration is you can use abbreviation where noble gases are used. Krypton 36, 5s1. So this is the address of electron which they are asking. To define the address of, to describe an electron, you need principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number.